Ratios and rates. Rates are ratios. Any ratio with different units in the numerator and denominator is called a rate. To solve most questions involving rates of all kinds, all we have to do is set up an equation of the form ratio equals ratio. We just match the units on each side. Remember that such an equation, fraction equals fraction or ratio equals ratio, is called a proportion. And if you're not familiar with it, it may be a good idea to go back and look at the video, Operations with Proportions, what you can do and can't do with a proportion mathematically. That video is in the fraction module. Rates are often expressed as so many units per units. So for example, all of these are rates. Many of these are drawn from science. The last two are special kinds, 60 minutes per hour or 360 degrees per revolution. These are examples of unit conversions. So these would be examples of things you would actually be expected to know. The other ones you would not be expected to know, but you would be expected to know that there's 60 minutes in an hour, and you can write this as a ratio. We would set this given rate equal to a fraction with the same units in the numerator and the denominator. So either the problem itself would give you one of the rates, for example, one of the blue rates, or you would know yourself something about the units and the way that the units are related. You set that up as a ratio, and then you set that equal to a fraction on the other side that matches the same units in the numerator and the denominator. Here's a practice problem. Pause the video, and then we'll talk about this problem. Okay, so this problem gives us a rate. It gives us the rate of 8 grams per hour. So that has grams in the numerator and hours in the denominator. So we're going to set this equal to a fraction on the other side that also has grams in the numerator and hours in the denominator. We're going to have 30 grams in the numerator, and then we're just going to have a variable. I'll call it h in the denominator. That's the unknown number of hours. The first step I'm going to do to simplify is I'm going to divide both sides by 2. So I'm going to divide the 8 by 2 and divide the 30 by 2. If that operation is an unfamiliar operation, if you're kind of shocked by that or didn't know that that was a possible thing to do with proportions, I highly recommend that you go back and watch the video, Operations with Proportions. Again, that video is in the fraction module. At this point, we'll cross multiply. Then to get the h by itself, we'll divide by 4. We get h equals 15 over 4 hours. Write this as a mixed numeral, 3 3/4 hours. We're asked when, which is actually a clock time. So we started at noon. 3 hours later would be 3 p.m. 3/4 of an hour is 45 minutes. So that means it's completely melted at 3:45 p.m. Here's another practice problem. Pause the video and we'll discuss this. A bumblebee's wing flaps 1,440 times in 8 seconds. So that's essentially a ratio. We could say it's 1,440 flaps per 8 seconds. How many times does it flap in a minute? Well, first of all, let's simplify that a little bit. 1,440 flaps in 8 seconds. I'm going to divide by 2. That gets me down to 720 over 4. Then I'm going to divide by 2 again. That gets me down to 360 over 2. And then I'm going to divide again. That's going to get me down to 180 over 1. So there are 180 flaps in 1 second. Well, we want the flaps in a minute. So clearly, what we're going to have to do is multiply by 60 seconds. Because there are 60 seconds in a minute. So the total number of flaps is going to be 180 times 60. We don't actually need a calculator for this. Let's think about this. Let's drop those zeros and make things a bit simpler. If we're doing 18 times 6, well, one way to think about this, the 18 is 10 plus 8. Well, I can do 6 times 10, that's 60. I can do 6 times 8, that's 48. I can add those two, that's 108. So now we're just going to add the 2 zeros. And so what we get is a product of 10,800, and that is the number of flaps in a minute. Here's another practice problem. Pause the video, and then we'll talk about this. Okay, this is very tricky. we have a couple rates. We have the 20 grams per centimeter, we have the $50 per gram, and then we have this initial starting amount, the starting volume, which is 2 centimeters cubed. So first thing I'm going to do is I'm going to start there. I'm going to multiply those out, and I get 8 cubic centimeters. Well, I want to multiply that by a rate so those cubic centimeters cancel. So I'm going to multiply it by that first rate, 20 grams per cubic centimeter. That way the cubic centimeters will cancel. Then I'd be left with grams. Now I want to multiply something so the grams cancel. If I multiply now by 50 grams, $50 per gram, then the grams cancel, and I'll be left with units of dollar. And that's what we're looking for. We're looking for the price. So I'll point out here, this is actually very easy now because 20 times 50 is just 1,000 times 8 is 8,000. So that would be worth $8,000. In summary, when you see problems with rates, remember you can set up proportions. Always remember to make sure that the units of the numerator and denominators match.